All right. Let me know if you can see my screen, but yeah, so thanks a lot for inviting me. I'm Daniiar, and I'm data scientist at a food delivery company, but I'm also a founder of CodeSquire.ai. CodeSquire.ai is an AI coding assistant for data professionals. Today, I'm going to talk about AI coding and AI-assisted coding in general, how it started, how it's going, and I'll show you how CodeSquire works. And I thought that it would be cool if we were to go live through the coding experience, or basically how so you can see for yourself that you can actually speed up your coding. And then I'll show you how possibly the future of AI-assisted coding looks like. So feel free, by the way, to ask questions immediately in the Zoom chat. I'll try to pull it up right now so that I don't miss any questions. Just a second, let me try to figure out how it works. One second. All right, now I can see the chat as well. So yeah, feel free to ask any questions in the chat as I go, and I'll be answering immediately. All right, so let's start. Basically, all of the current models, like the most famous application is probably GitHub Copilot. It's actually based on OpenAI Codex. Now, what's interesting is that OpenAI Codex itself is actually just based on GPT-3. It is absolutely the same architecture. The only difference is that OpenAI Codex was trained on lots and lots of code from GitHub. And GPT-3 model, it's a text generation model. It has around 175 billion parameters, which is a lot considering that GitHub Copilot uses usually a model called Cushman, and that model is just shy of 6 billion parameters. So it's way, way smaller, but still really powerful. Let's see. Now, how it's going? Well, lots of, after OpenAI Codex launch, lots of other companies, all big tech companies, also released their models. Some are open source, some are closed source and are not available for public, but available in terms of research. One of those models is GPT-J. And there are two versions. One version was trained on lots of text, so it's text generation model, and another model was also trained on GitHub code, and it has around 6 billion parameters, which as I said, is plenty for inline generation, similar to Copilot style. And you can deploy GPT-J on TensorFlow on like a regular GPU without any issues. Well, when I say regular GPU, I mean probably like A100 for sure, but on a single GPU, like you don't need a cluster. The other model is Google Palm. That one is huge. It has 540 billion parameters, but just because of the way they trained it. And it's not released in any form, nor open source, nor like through API. So we're just gonna have to wait, I guess. Another interesting model is called DeepMind AlphaCode. Now that one has 41 billion parameters and is probably the biggest so far out of the models that are designed to generate code. And AlphaCode is extra interesting because it's actually able to solve not just different coding problems, but like really hard Olympiad level problems. But it's also, unfortunately, is not released in any form as of now. Another model is called Amazon Whisperer, and that one is not released open source, but you can use it if you join their waitlist and then you go through it. It's very similar to GitHub Copilot. The difference is it generates better code associated with AWS services. And Probably my favorite is Salesforce CodeGen. This model is really powerful, on par with GitHub Copilot. Some versions are actually even more powerful. And most importantly, it's released open source. So everything, the entire code plus the model weights. So you can actually start playing with it and deploying it on your own hardware. Replit recently released Ghostwriter, a competitor to GitHub Copilot. And Ghostwriter is actually based on Salesforce CodeGen that was optimized by like pruning and different techniques, binarization, where you basically make your model smaller. Now, so what can AI coding assistants can do? They can turn comments into code. They can help write code with different libraries. Probably the most useful use case is when you don't know the syntaxes or the methods of the library, kind of helps you navigate that. You can write complex functions if you specify multiple steps. But most importantly, the entire code is tailored to your coding style and use case. It's very important because we technically could always just Google and find the answer in Stack Overflow or in some documentation. What makes this experience entirely different is because AI actually adapts to your particular use case. I'll show you what I mean later. So how powerful those AI coding assistants really are. Here's a video that I've made of a parser. I created a really simple parser that goes into lead code, goes into hard section, so only hard problems, parses the task at hand, like in this case, it's at a distance, then writes solution and submits that solution. As you can see, the submission was successful. And then it goes to the next problem, and so on and so on. So you can basically run it overnight and get lots and lots of problems completed if you wish to, which really, to me, means that even before, like everyone was questioning on whether interviewing people on lead code makes sense, but right now I think it makes even less sense than before, just because there are those AI algorithms that can solve lead code problems very easy. All right. Let's see. Okay. Now, it all sounds great, but it's important to see whether the productivity that we can kind of perceive from AI coding assistants is an actual productivity or just an illusion, just a perception. Turns out it's an actual improvement, and there was two like actual academic and peer-reviewed research about that, and one research is from Google and another is from GitHub, both in 2022, of course, since the technology is so new. And you can see that it actually has an impact on KPIs. So, for example, leaving IDE to Google, whatever, it's 7% reduction, or certain percentage of the code that was generated by AI, and 6% reduction in coding iteration time, just time between build and tests. And this is just from one study. There was another study that provided even bigger numbers, especially for the new code generated around like 20–30%. It might sound, by the way, like not a lot, but if you think about it in terms of the impact on the entire organization that, let's say, adapted an AI coding tool, those percentages obviously add up to free hours that can be used for other tasks. Now, in terms of where are we going with that? Research goes into the direction of specialization. So people are interested, researchers are interested whether you can use AI-assisted coding in certain specified areas. And the reason for that is because it's a natural progression, I believe, of any powerful technology, where a powerful technology appears and you kind of see how you can use it in one way, but then you start to see that if you add certain parts, then you can use it even better. Like, for example, Pix2Code is an algorithm that allows you to translate pixels into code, which means that you can potentially take a screenshot of a website that you like and get a clean code. Probably easier to parse HTML, but let's say HTML is unavailable for whatever reasons. Obviously, it can be also a screenshot of a Figma design or just a wireframe. There's another research called Topical, which learns representation of the repository, which is really important because we usually code in some sort of a project. So it's not just one file. So right now, Copilot basically and other similar tools and CodeSquire as well looks just at the notebook or script itself and nothing else, which is a mistake because when we write code, we kind of split the code between different files and different modules. So information about those different modules is very important to understand as well. A simple example of it would be if you have two files and one file is just a module from which you import some utility functions, let's say loading a data frame to cloud storage, and you have that function. If you were to write a comment in another file saying, can you load this data frame to cloud storage? Copilot would just start writing a function to do so. Even though it's a mistake, since you already wrote that function, it just has to be imported from the previous module. So it's a challenge to make sure that AI understands everything, because obviously repositories can be really big. And one way to do it is through embeddings and similarity search. And that's what this paper is all about. Now, why CodeSquire even is needed if I was talking all this time about Copilot and all other models and tools? Well, the reason why is because I'm a data scientist, and as I said, looking at the research, it's clear that the entire industry goes into specialization depending on the certain, I guess, topic or industry specialization of code generation. And since I'm a data scientist, I know lots of pain points that data scientists have when it comes to writing code. So naturally, I started looking into that, and two things that became immediately obvious to me where Copilot and the rest fall short are experimentation. So as data scientists, we do lots of experiments, and that's why notebooks are so popular among data scientists, because you don't have to rerun entire code. You can just run cell by cell, make little changes, run another cell. So advanced notebook support is really important. Copilot right now supports only notebooks in VS Code, which isn't good enough since lots of data scientists use Jupyter, Colab, or Databricks notebooks. And the second point is probably way more important, is data awareness. What do I mean by data awareness? Data awareness means that AI takes into account not only code context, so not only the code written before or after, but also data that you work with. It can be a data frame, it can be a database that you're working with, and etc. The reason why it's important to understand that is because you need to understand columns and data types, etc. So first of all, as I said, AI coding assisted for data science should have advanced notebook support, and CodeSquire already supports Colab, JupyterLab, BigQuery, as well as Databricks notebooks. It should also take cell outputs and markdown into account, something that Copilot doesn't do. So for example, in this Here I wrote in VS Code, as you can see, I wrote get sum of all orders, and there's a data frame with product with number of orders. The recommendation that I got from Copilot has to do with date, even though date is nowhere to be found, nor in the data frame, nor in the markdown. The reason for that is because Copilot just doesn't see those things, and it's an issue. Another example would be SQL support for multiple tables. Again, basically data awareness. Right now, SQL support in Copilot is basically useless because there is no understanding of what tables you work with, what columns you work with, how do they look like in terms of data structure. All of that metadata has to be embedded. And if you were to write down all of that metadata yourself into, like, let's say, comments or into ChatGPT, it would work, but it would take you eternity. It's easier to just write a query yourself. So that's another problem with Copilot. Another frequent use case that I feel like especially important for data scientists is the feature that would allow data scientists to translate pandas to more performant alternatives with just a click of a button. We all know the problems that pandas has when it comes to compute and memory and in general, just speed. However, pandas is still the most sophisticated library when it comes to wrangling with your data. So that's why it's the most popular one. So if there was a feature that would translate whatever pandas code to like Spark or Dask or Modin, right, or whatever, would obviously be really useful. And the next point, which is kind of far-fetched, but still would be really nice to have, is once AI has access to code context, markdowns, and data, it can potentially recommend next steps. So you suddenly have an entirely different experience. You don't just ask questions, but you also get recommendations from AI. E.g., you can ask a question today, like what granularity does this data have, and it would provide you an answer. Let's say a data where AI would provide you an answer. But even better would be if an AI can say, hey, I see this column has a lot of missing values. Do you want to fill them with mean value or with median or whatever? Or maybe do you want to take a look at distribution of this column? It appears to have lots of outliers. Maybe you want to remove them. And here's the an algorithm to remove outliers, or here's a box plot for you to take a look closer at outliers in etc. So let's go to demo. Before I jump to the demo, I'll take a small pause. Do you guys have any questions? Feel free to type them in the chat. And if not, we can just go straight to demo. All right. Seems like no questions. I don't see any. Okay, cool. Let's see. Yeah, I think it will be better if I'll just open this one. It doesn't have anything. So for demo, I thought I will just go with you with a simple, we'll run a simple RFM clustering. I'll explain what it is for those who don't know. Just a second, let me download this. I'm downloading this sample dataset that I found on Kaggle. Let's see. All right, while it's loading, I'll explain what RFM clustering is. So RFM clustering kind of relates both to product analytics, but also to data analysis. It's very common and very basic type of clustering where you look at your users and you split them by RFM, which stands for recency, frequency, and monetary value. The reason why you would want to split your users by RFM is to quickly kind of understand your most valuable users, your least valuable users, your kind of median users. And based on that clustering, you obviously can make decisions like, should I send advertisement to those users? Should I not bother them because they're like frequent users and they're using our tool? Or maybe there are some users that are using the tool or whatever, your service frequently, but they're not paying as much, and you might want to find out why and maybe upsell them with different services that they're not using. Or maybe different monitor value is really high, but frequency is low, which means that that user is buying only like making only big orders, let's say. Maybe you want to change that and offer something else. And of course, the analysis of problematic users whose recency is low, and or rather, yeah, recency is low, so they used the services a long time ago and not frequently, and you want to understand why is that happening and just size up the problem. So it's a simple tool, simple clustering technique, but can potentially be really useful. I thought we can go through that and see how AI can help us do that faster. So the way it works is I already have CodeSquire.ai installed on my Google Chrome. It's basically a Chrome extension. So it's already integrated with Google Colab, Jupyter, if I were to run in Jupyter, or Databricks notebooks, and you don't have to reinstall it every time. So it doesn't work like a library. You don't have to like update it or reinstall it. It happens all automatically. So let's start. Basically, all I do here is just write some comments, nothing much. So I guess first thing that I'm gonna do is create a bunch of cells. And as you can see, it already starts recommending me some code, which is standard libraries to import, but let's not take everything. I'll just take pandas. It's enough for me. And then I can see that the file is in zip, which means I cannot read it with pandas. So what I can do is I can say unzip online retail, and then provide the command function. And as you can see, it provides me a recommendation immediately. The only problem is it's incorrect file name. So I guess I'll just do that. I'm not sure whether it will work. So I will just do this. Really quickly, it's easier to edit the file name. And let's see whether it works. Yep, it appeared to work. And the cool thing is that, as you can see, immediately the next step, it recommends me to read the actual file that I just unzipped. So I just press tab to accept the code recommendation, and let's see whether it will work out. So I can see that it says some Unicode error. So apparently encoding is different. So let's fix that. Usually ISO works in case like that. And as you can see, I don't have to remember all of the coding names that recommends me the coding that might work. And indeed it did work in this case. I guess I can close that. By the way, let me know if my screen is too small and you can see the code. I can increase it. All right, so looking at the data set, we can see that it appears to be on order or product even level, on product level. Okay, screen says okay, great. On product level, we can see, and the reason why we can see that is because, well, invoice number gets repeated, customer gets repeated. The only thing that appears to be not repeated is like stock code and this product description. You can see quantity and price. So the first thing that we need to do is we don't have revenue, so we need revenue in order to calculate monitor value. So let's do that. Let's calculate revenue. And let's see, yep. And as you can see, it immediately provides us with correct code to do that. You can check. By the way, probably a good idea to call it BF orders, since it seems to be sort of on order level. So it makes more sense to do it like that. All right, so now we have revenue. So in order to perform RFM, we need to create a table on user level, since it's a user clustering, and each user would have recency, so the latest purchase, frequency, which means how many different orders the user made. It also can be a different type of frequency depending on your business, maybe like number of days, let's say, number of different days. And monetary value is just how much in total the user has spent. So let's do exactly that. As you can see, while I was explaining, it already provided the recommendation. It says here, create user level table. And what it does here is that it groups by customer ID, which is exactly what I need, and revenue, as well as invoice count, which is, I guess, not exactly what I need. Let me fix that really quickly. So first of all, I don't think I need count. Yes, and as you can see, it already fixed that. No, why it's red. Guessing it's something has to do with linter of the Colab. Yeah, okay, it's fine. So revenue sum, that's correct. Invoice number, since it has to be unique, since it's on product level, but on order level, it would be unique. So we have to, that's why we can't use count, we have to use unique. And the last thing that's left is, so we have monetary value, frequency, we need recency, which I guess we can just take a look at the latest date of purchase, so latest invoice date. All I have to do is do something like this. And yep, here we go. And it already recommended me max, which is exactly what we need to get the latest. Before we do that, I don't like this format, so I'll probably convert this to typical datetime. So I just say I like the datetime column invoice date, and I should get the right code. Yep, there we go. And it should now work. Let's see. Yep, and just like that, we have our data frame on user level, as you can see, showing revenue and invoice number, invoice date. Now, interestingly, for this customer right here, the revenue is 0, but invoice number is 2, which means that there were 2 orders. So let's try to understand what's going on. So orders for customer 1, 2, 3, 4, 6, convenient ID. It provides us with code. Okay, so it provides us on user level. That's not what we need. We need DF orders, so we can just substitute it really quickly. That. And we can see what's going on. So basically, some weird thing where that customer ordered lots of whatever that is, and then for some reason there is like a minus. Probably has to do with something with the business or data set, but just in case, let's go up here and just filter everything, filter to make sure that the quantity is always positive. So there's no such thing as negative quantity. This kind of makes no sense to me. So we just say filter positive one. Okay, and we've got our code, so we can do that. Okay. Okay, great. So it appears to work out, and now the customer has actually some revenue. Great. So we cleaned up a little bit the data set. Now what we need to do is, as you can see right now, our main user level data set looks like that. So we have revenue, or monetary value, we have invoice number, or in other words, number of invoices, so number of orders, frequency. Now we need to convert our invoice date to recency, which basically means subtract today's date minus whatever that invoice date. Today's date would, well, as you can see, it already kind of provides us, right, with this code to subtract today's date minus invoice date. The problem with that is the data set is in 2011, so I'm guessing the data set was made, when the data set was made, it was like 2011, 2012 probably. So what makes more sense is to just first calculate the max date. Then it does it for us. See? And you can see that it's 2011, and only then we can calculate recency. All right, let's see what's going on again. Some weird issues. Okay. See. All right, good. All right, so now we have recency. Great. So technically now we have everything. We don't need invoice date anymore, so we can drop invoice date. Okay. Great. Yeah, this Colab skip not liking lint for some reason. See. Okay. Now we can rename probably our columns so that it's named correctly, like frequency. But first, let me set index. We'll set index as customer ID. As you can see, I can easily make typos, but it understands what I actually mean. And after that, I can rename my columns. Yep, and it renames them exactly the way I want. Maybe instead of revenue monitor. Yep. Great. And it even understood now that I like to kind of run .head and after every manipulation, so it's immediately recommended me that as well. Okay, so now I have customer ID and I have monitor value, frequency, and recency. So now I can already start doing some clustering. But before I do that, a good idea would be to just plot the values as they are and just see ourselves whether we can kind of see with our eyes whether there are any clusters. So to do that, I'll just, this comment is kind of useless at this point. All I'll do is I'll write plot 3D graph showing recency, frequency, monetary value. Let's see what it says. Okay, so it provides me a standard matplotlib. I don't like matplotlib. Let's use plotly instead. All right. Okay, let's see. Okay, here we go. And we've got our 3D plot. And already we can see some interesting cases like this customer right here, for example, had purchased something recently. Frequency is relatively low, like compared to some of these customers, but the monitor value is really high. So clearly this customer is probably buying something in batch and etc. As well as these customers are probably really valuable. Now, what we can also see, and this appears to be a bulk of customers, are the customers whose recency is low, meaning that they purchased not that long ago, but the frequency is really low as well as the monitor value. So these are probably our kind of like medium customers. And then we have customers over here whose frequency is really low, recency is really high, which means that they've purchased a long time ago, and monetary value is really low. These customers most likely already have churned and not using our services anymore. So we can either ignore them and concentrate our efforts on like our median customers and our almost outliers, right? Our main kind of business, or contrary, maybe we can concentrate on those and try to kind of get them back to our business. Depends on how we want to act. But this graph already kind of shows a lot to us. But now let's try to visually separate all of these using, well, clusters. So the first thing that we need to do is we need to scale the data. It doesn't like have to be, but I like to scale it. So as I wrote already here, like scale using standard scaler. And as you can see, it provides me all of the code to do that. Let me see. Yep. All right, appears to be correct. Let's check. Why is it? Listen, it's white spaces are incorrect or something. All right, perfect. Now, and bunch of code here. I believe scale df here is actually a numpy. Yeah, we don't want that. We want the actual data frame. So let's do it the following way. We'll call it scaled. Then here we'll call it scaled df. Then let's see what it will recommend. Yep, and it recommends us exactly what we need, which is converting numpy to the data frame using the columns that we know. However, it's missing index. So let's add index. And now it added index. Let's see how it looks like right now. Okay, perfect. So we have exactly the our previous user level data frame, but now it's all the values are scaled. Great. So now we are ready to do some clustering. So I'll be using just simple k-means. So let's do the following. First of all, as you can see, it already kind of recommends me from sklearn cluster import k-means c. But let's think about it as first. We probably don't want to just pick a random number of clusters. Let's try typical elbow methods, so number of clusters. I'll just pick randomly from 1 to 6. And once I did that, once I created this basic setup, as you can see, it already recommends me next steps. So now all I have to do is, I guess, plot this. First, yes, except I don't like plot libs. So let's do. Okay, perfect. See what happens. Perfect. And just like that, in like a couple of comments, I guess we created our several clusters and elbow methods, and clearly we can see that 3 looks like the best number of clusters. So now we can safely just use just do k-means with 3 clusters. So okay. Let's see what actually that happens. And at this point, I'm barely even checking the code, to be honest. Let's see what happens. cluster. Okay. All right, perfect. So it added, it ran k-means on 3 clusters, and then created this array of labels, and then added that array back to scale.df. So now we have our previous user level data frame, plus we have our cluster labels, which means that we can easily visualize again our monitor frequency and recency values, scale this time, but it doesn't matter. We basically what we want to take a look is the clustering, so that's fine. But most importantly, it has now cluster labels, which means we can use that to color our data. So let's do exactly that. Okay, now upload 3D. Use cluster as color. Right, perfect. And cluster labels. Yep. Perfect. All right. Perfect. And as you can see, like our first look at the data was was basically correct. We kind of identified that these customers are the ones that we want to take a look at because they appear to be the most valuable. The customers right here are kind of the medium level customers, and the customers here are low level. And we now can see that in terms of algorithmically, it is exactly the same picture. What now we can do is we can easily just pick, let's say, most valuable customers, right? So that is cluster label 1. So I can do this. For 1, right? Is that 1 or 2, 0? No, it's not correct. It recommended me 0. I need 1. Cluster labels 1. Yeah. Now do that. Linking here doesn't work properly. So, and these are basically all of the customers that are most important to me. Now, these are all scaled versions, so you can just do the same thing, but on non-scaled DF, and you'll get actual monitor frequency and recency values. But immediate action item here would be to perhaps email our gratitude to those customers because they're so valuable to us. So yeah, that's basically how it works. The other cool feature of CodeSquire, besides, as you saw, I was mostly using it to translate comments into code and kind of like quickly generate it, is that you can actually specify all of these steps above in multiple, in a doc string like that, as multiple steps, like do k-means clustering is 4, let's say add cluster to the TF, and then visualize in 3D, and then you can press Command Shift E, and it would start generating you a bunch of code that you can just copy paste instead of checking all the time, in case you feel like extra lazy. So that's possible as well. Now, besides that, what I wanted to show you as well is this. So the first demo that you saw here was me generating code Copilot style, but in Google Colab. Now, what my team and I are working on right now is truly data-aware AI, the one that truly understands the entire data set plus code context, plus questions, answers, etc. And what it allows it to do is to answer more complex questions and more precisely. Here's an example. No, it is pretty raw demo so far, but let me try and see whether it works. I'll refresh it. While it's refreshing, I'll see a question. What information about data frame does CodeSquire know and can use? Yeah, so right now it takes mostly only code context, but the next version will be using data frame metadata like column names and that column data types, as well as data preview, so like head 3. That's it, I guess. That's really the only metadata that you need for the data frame. But in this example that I'm showing, it takes way more metadata because it's actually connected to our analytical database. So what you can do here is you can ask questions like create a table that shows user ID and number of requests made per user, let's say. So I'm asking a question. It'll take some time. Let's see what happens. All right, so and it returns a query. Now the cool thing about this query is that it's actually is using correct table names, correct columns in the DB. So not only it is the right syntaxes, but as you can see, I didn't have to make any edits. I could just run it and it returns me correct information. This user ID this user clearly is loving our tool. Now, the other question that I can ask potentially, I can ask all sorts of questions, but the cool thing is that I can ask question on top of question. Oh, yeah, sure. Sorry. Let me do that. All right. Well, that's better. You can ask questions on top of questions. Like you can now say, what is the total number of requests made at all, right? So, or what's total number of unique users? Or let's ask a question something like, can you get only users and their number of requests, only users who made more than 5K requests, for example. And looks like it doesn't want to. All right, no, it's fine. Yep, and as you can see, it was able to take the previous context and just modify depending on the question, where here it's having count more than 5,000, a bit more advanced, I guess. And etc. And this is the true potential of AI once you give it all the necessary context. And let's talk about the future now. Let me go to the slide. All right, before I move on, any questions, any other questions? It looks like no other questions. All right. So, so we saw the demo. We saw how it basically completes code in the notebook. It takes into account data metadata. We saw a more advanced version, a bit uglier one, yet still didn't polish the design, but way more advanced than Copilot in terms of understanding the actual underlying database and what columns to use, what tables to use, etc. Now, again, it's important to understand that the entire industry is still new, and we are at this pre-WordPress age probably, or maybe at WordPress age, where WordPress would be something like GitHub Copilot, where it's like a really big software and it made our lives way easier. However, the next step is going to be specialization, where on top of those large language models that generate code or text, there will be different specialized applications for different niche. And for coding assistants, it will be the same thing. I believe it makes sense. So I'm data scientist, obviously I'm working on data specific one, but I also think that it makes sense to create an AI coding assistant for front end, for example, where you have immediate interaction between how the browser, how the website or app looks like and the code that you're writing. And you can potentially create a feedback loop that feeds itself and creates an application until completion, similar to noise and GAN, where out of noise appears an image. This similarly, like out of a blank coding page can appear entire application, etc. The other thing that I'm confident in, and I can see clearly that it's already happening today, is transition of AI-assisted coding to norm. So here's what I mean by that. Still, because technology is still relatively new, even though lots of developers are already using GitHub Copilot, CodeSquire, and other AI coding assistants, it's still new to organizations and to some developers. It's not as prevalent as, let's say, VS Code or PyCharm, where everyone just uses it, and no one is using, let's say, like notebook to write code and then save as .py or .js, whatever. So it will become a norm. And it will not be called, like I was keep saying throughout the presentation, I was keep saying AI-assisted coding. It will be just code coding, and that's all. And it's really important to understand that, because if you think about something like accounting or finance, people back in the day would use something like Abacus. Right now they're using calculators, or even not calculators, but some specialized software. The craft itself is still called accounting. It just became way easier. And the same thing with coding. Coding will still be coding. The only difference is that it will become way easier, way more efficient, way more powerful. And even though AI tools have appeared just recently, just as powerful tools as CodeSquire and Copilot and TC Codex, if we think about it, coding was getting easier for quite some time now. Like, the first languages in TC were all low level or close to machine and were incredibly difficult. Then there were high level languages like Python, JS, and other PHP. And now we are transitioning from those programming languages to natural languages, English and other languages. But the craft itself, I think, will stay the same. So there will still be coding. It's just perhaps the language that we will be using is not going to be Python or JS. It's going to be just English. The other important point that I want to make, and I think that I really want to, I want you guys to kind of get out from the presentation, is that what we are experiencing right now is a fundamental shift in the paradigm of how we interact with computers. And it doesn't have to, it's not only has to do with like data applications and data science, but in general with the way we interact with computers. Because it used to that, well, it still is, because it's still in adoption phase, but we are telling computers on how to solve problems. And I strongly believe that soon we'll be telling computers what problems to solve, and it will be just solving those problems to us. And an analogy to that would be an elevator. We just press a button if we want to go up, and it comes to us and then takes us to the floor that we need to. we don't tell it how to do it. We don't tell it, hey, I'm on ground floor, go first down 5 floors because you're on the 6th floor, or 6 floors, I guess, because you're on the 6th floor, and then like open the doors, wait a bit, and then go back to 7th floor because I pressed the button 7. We don't tell all those things. We just tell it what to do, and it does it for us. The other important point here is from transition from how to what, is that this transition is a natural transition every time we talk about true expertise. What I mean by that is if you're, let's say, in a restaurant and you're ordering food, you don't really tell how to cook that food. You just tell what you want and the chef does it for you, unless it's like steak, maybe ask you how you want to be done. Or if you go to a hospital, you don't tell a doctor how to cure you, you just tell what problems you have with your health. This transition from how to what enables a new type of collaboration and contribution to data science and to data analysis, or maybe to software development as a whole. And this collaboration is collaboration between tech users and non-tech users, business stakeholders, who now will not be just passive consumers of the software or of the data analysis that you have developed, but now will be able to directly contribute to the data analysis process. And I think that's really exciting because suddenly it makes data analysis process not only just quicker, because as you remember previously, all numbers that I showed you in terms of improvement had to do with productivity improvement. So faster coding and etc. But once we switch from how to what, not only speed will greatly increase, but maybe even more importantly, quality, because suddenly non-tech users can also contribute directly to data analysis or software development. So I'm going to wrap up here. In conclusion, using AI for coding is a must today. So if you're not using it, you have to. And data-specific AI is needed for the reasons that I outlined, because Copilot is not enough. And that's why I'm building CodeSquire. And keep up to date with CodeSquire.ai, and we have exciting roadmap and lots of really cool new features coming out soon. So please give it a try and let me know what you think. It's free. So yeah, that's all.